All right. Hi, everyone. My name is Mike Verrilli. I'm a customer success architect with Talend. I've been with Talend for a little over 2 years. And so I'm actually on Dale's team. Okay. And so today we're going to go through the third and fourth parts of the best practices. So you've already seen, who here has seen the first two parts? Okay. So not too many. Okay. So there's a lot of new faces here. So yeah, I think as part of the, if you signed up with the email, what we can do is we'll make sure we send out some links to you for some of the videos, because a lot of people haven't seen the first two. You don't need to see the first two to see these, so there's not a whole lot of overlap. It'll be just fine. So let's see. We'll be going through some SDLC development guidelines. We'll do go through the database modeling, and then we'll go into the best practices, so job design patterns and best practices. And it's an open discussion, right? So, have any questions, raise your hand, and feel free to just shout it out, and we'll talk about it. All right. All right. So, regardless of what kind of tool you're using, or if you're even coding or what have you, you're always looking for what is the best way to use that tool, right? In Talend's case, what's the best way to write a Talend job? And so you want it to be easy to read, easy to write, and easy to maintain. But really, it's hard to do all three, right? So you have to kind of choose based on your requirements, right? So if the job is going to change a lot over time, then you'll want to make sure it's easy to maintain and easy to read. If it's not likely to change, you'll want to make sure it's easy to write and easy to read. And if there's many developers touching these jobs, then you want to make sure it's easy to read and easy to maintain. So with Talend, you're basically painting code, right? You have a canvas, you have all your components, you have your palette of components, you have your repository of objects, the metadata objects that you've created, and you're able to drag them in and graphically create basically what's a program, right? Talend is a code generator. But even though you're not coding, the basics still count, right? You still have to think about error handling. You still have to think about memory management or performance of what you're doing. These are all things that fall into the best practices. Just like coding, even though you're not, you still want to avoid some complexity. You want to avoid monolithic jobs. Just like if you were coding, you wouldn't want to create one large function that does everything in the world, right? You'd want to break it up. Similar in Talend, right? So we have the SDLC Best Practices Guide. This is something that you can find in our help.talend.com. It's pretty easy to find. You just type SDLC Best Practices, and you can find it. There you'll find references to what are all the moving parts with Talend, right? There are a lot of moving parts, and you really need to understand which parts of Talend are you using, and how these things interact together. So you also you should create your own architectures, diagrams, and understand how your architecture compares to our references. Also, we do support continuous integration. We do Maven builds with Talend, and so within the software development lifecycle, we do have a lot of documentation around how to set up Jenkins, how to do unit testing, and all the typical things that you would find in a continuous integration and continuous deployment environment. Right? Let's see if the links work. I can show you basically the best practices guide. Is it coming? Yeah, okay. A little hard to do. With the trackpad too, right? Okay. Phew, there we go. All right. So this is our best practices guide, and in it you'll find lots of really good information about how to do all that setup. A lot of the references of the reference architectures of what parts are in the builds that you're, what services that we have that are in the builds that you're going to be creating in your continuous integration environment. All very useful stuff. Definitely recommend reading that. See if I can move forward. So something else you'd like to do is, create some guidelines, right? Did I skip a page here? Sorry. All right, guess not. All right, so something else you also should do is create some guidelines. And when you're creating your guidelines and you're creating your projects, there are these foundational precepts. They're basically like non-functional requirements that you might have in your projects, right? So of these foundational precepts or these somewhat non-functional requirements, which two would you say are the most important? Go ahead. Yeah, pick two. Go ahead. Can anyone pick two? You get a sticker. How about pick one? Functionality. Okay. You get a Talend sticker because you're the first person. You said something. Okay. All right. Functionality. Okay. Any other guesses here? What's the most important? I'm sorry? Good. Optimization. It's a good one for sure. Reusability. Yeah. That's really good. Yeah. The reality is they're all kind of important, right? But it really depends on what you're doing and what you need to do and what your requirements are in your project, right? In some cases, you may need, lots of scalability, right? Especially a lot of these big data type jobs or what have you. So you're looking for scalability. Reusability is always a good one, right? Make sure you're not reinventing the wheel 100 times, in your projects. So these are the things that you want to consider when starting your projects. Right. So what you're doing here, though, is you're building these guidelines, and we're calling them guidelines because they need to be able to bend a little bit. You don't want standards that that break, basically. With standards, it leaves no room for growth, right? So there's a lot of unknowns in every project, and so you want to make sure you always leave a little bit of bending, right? So we recommend creating a development guidelines document, and we actually have a sample document that I don't have a printout of, but we can send out with the link, so we can do that. But as part of these guideline documents, you want to define, what is your SDLC? How do you plan on how do you plan on having all the developers, check their code in and out? What are some of the conventions that you might be following? Your naming conventions or your error codes or what have you. You may also want to create data dictionaries and define your data access layers. How you're going to define these things is really what you want to put in your guidelines, right? Handout, which I'll send out the link. All right, and just one more thing. Really, you want to start easy and start with something that everyone can do. If everyone agrees, for example, to name every one of their components, that's a start towards some best practices. And then over time, just keep adding to it and just keep building on that, right? And over time, the discipline of your team will improve, and your code will be, or your jobs will be easier to read, write, and maintain. So now we'll talk a little bit about database development lifecycle. So your jobs have life cycles, right? Your code that you may have has life cycles. Your databases, do they need life cycles too, right? The answer is yes, they change. So anything that changes that you're working on, you're going to need a life cycle around it to manage it. So that's what we have as a database. We recommend defining your database development life cycle, and we have some ways of doing that. So how does it work? Right, so you look at all the things that you need to cover inside of your database development lifecycle. You'll need to be able to do fresh installs, right? You'll need to be able to do upgrades. You'll need to migrate your schemas, right? And your data models change over time. You're going to be altering some tables. You're going to be recreating some tables. Repopulating maybe certain lookups or what have you. These are all things that you have to take into account with your database development lifecycle. And also is how you plan on managing those releases. Your change, how you're going to do your change scripts for your object creation, things like that. And then you have the methodologies for doing the data modeling. There's lots of different data models out there. Depending on what type of application you're working on. Hierarchical models you don't really maybe see quite as much now. Network models like graph databases that you see, or social networking, or what have you. Relational, everyone sees those every day. Star schemas, snowflakes, starflakes, all these analytical schemas that you see. These are all things that you see very often. But then you also have Data Vault, which is also something very interesting. Who's heard of Data Vault? Okay, got a few people. Yep. So Data Vault is something. So when you're working in big data environments, and you may have noticed that Star and Snowflake and what have you don't really necessarily work too well in big data environments. In big data, it's not very good at doing inserts and updates and deletes, for example. And Data Vault has a really nice, organized way of getting data into a data lake in a way that you can actually just keep continually inserting. And so it's very compatible with big data environments. So it's something, so if you're looking to do a data lake and you want to organize your data really well, Data Vault may be something that you want to look at. We're not going to really cover that today, just something I'd mention. There's also all of these data model design is based on some blog entries here. Which I don't know if this link will work. We'll see. So these are Dale's blogs. If I can manage to get this working. Let's see. There we go. So we have a lot of blog articles on our site, and you can go to talend.com/blog. So Dale Anderson, who's actually back there, he wrote many of these really great articles. Yeah, I'm kind of expected it to. What's going on here? Ah, there we go. All right. So a lot of what we're seeing today is actually originally based on these blog articles. So specifically the one that we're talking about now, the database development lifecycle, you'll find a lot of that here. But if you go here and you find any of Dale's, you can actually click on his name and you can see a list of all his blogs. You'll see, part 1, 2, 3, and 4 for the job design best practices that we're going to talk about in a little bit. You'll find, some things about Data Vault, data model design, best practices, things like that. Yeah, very, very useful, very popular blog series. Okay. And also, we want to look at the data modeling process, right? I like to start at the physical. I think everybody probably goes straight to the physical, but you probably shouldn't, right? You really want to start at the top level and kind of work your way down. Everyone is probably very familiar with the physical layer, the logical layer. This is like DDL, right? And then logical layer, you're just talking about entities and how they relate to each other, right? And then going a step up, you may have like a conceptual layer. This is a little more of a business layer, right? These are putting it in terms that everyone can talk to, right? UML or something like that, right? And then there's this idea of this holistic layer, and this is very high level. Where is all this data coming from, and how is all this data coming together? At a very high level. This is something that's very often missing, but very important for everyone to understand. So here's some examples. Dale's really good at making pretty charts, so I always like the bubble one. So here's just an example here. So like the holistic one here, it talks about you won't really be able to see, but where the data is coming from and kind of where it's moving to, and then you have the logical models, which is kind of like a UML, right? And the conceptual model was kind of like UML. Then the logical, which is an entity relationship, kind of somewhat simplified. We're not going through every little nitty-gritty detail. And then you have the physical, which is the complete detail of the model, right? And of course, you're going to want to define your data dictionary, right? Everyone across the company, who's working with your data needs to understand, what the data is, where it comes from, what it's about, right? And that's all the data dictionary. You'll want to make sure that you definitely have, a good introduction for, what is this set of data that we're working with? Where does it come from? What do these entities represent? What are the keys for this, this entity? And then all the details about, what the expectation is for each one of those columns, right? So those are some of the things that you would find inside of your data dictionary. All right. So now we're going to get a little closer into where, these actual best practices. First we'll talk about, what are design patterns, right? These are kind of like skeletons or, templates that you can use, or if not actual templates, then at least the idea of what you should be doing with your jobs. The idea is to keep everyone on your team on the same page. So when you adopt a repeatable coding style and everyone is following the same guidelines and everyone's following the same best practices, whether it be best practices that we have or some that you've created yourself, following them will make your code easier to read, write, and maintain. And that really is the goal. All right, so we'll do a quick recap on just a couple of the best practices from the last session. These are kind of easier ones, kind of like a warm-up, right? So best practice number one is, how do you lay out your jobs, right? You could lay out your jobs in a zigzag pattern, like this, right? Or you could lay it out, kind of snaking around. The issues with these methods of laying out the jobs on your canvas this way is, the components on your canvas this way is, when you need to modify them and add new components in, you end up creating this cascading effect of having to move everything just because you want to insert one or two components. And often you're doing this because maybe you're trying to keep everything in a single view, right? And really the issue here is, you're creating a lot of work for yourself and you're probably not getting a whole lot of benefit out of it. So we generally recommend, it also depends on your monitor size, right? So, you may have a really big monitor, somebody else has a really small monitor, and when they open the job, it doesn't even look the same as what you thought it was going to look, right? So really, we just recommend, top to bottom and left to right. You can scroll. You'll know when your sub-jobs are moving off the screen. It's not that hard to scroll. It's a lot easier to maintain. It's a lot easier to add new components in if you need to. So this is generally what we recommend. Yes. Right, and we touched on this a little bit earlier, but another best practice is don't create do-everything jobs, right? Don't try to create parent-child relationships and do some orchestration, right? You may want to have some sub-jobs that are specific for certain things that might be able to be reused, for example. And it's pretty easy to do. There's a t-run job, right? You can use a t-run job, and you can just call out another job. Basically, this parent-child hierarchy is a very common thing. Even when you're doing like big data jobs, you'll use, like, for example, a DI job, and you may have some orchestration between other DI jobs and some big data jobs that you have. That's a very common pattern that you might see. Something important to note on the, of course, it's going to come over here first. Hold on. All right. Getting there. All right, hopefully we can see that a little bit better. But so some things I wanted to call out real quick here on the T-run job is, so what you see here first is the whole parent job, right? And you're calling this child job here, okay? And we have pre-job and post-job, which is actually some of the best practices from the first set, which are some things that you can have execute before the job actually starts, right? And at the end of the job, right? So anyway, so you have this child job here that you're calling out from this parent job. And there are some settings that you really want to be aware of when you're using a T-run job, okay? The first one is whether or not you want to use an independent process for that. And it says subjob. Probably a better term would be child job in this case. So do you want to use an independent process for this, okay? So this basically means, do you want to run another JVM? Or do you want to run it within the same JVM that the parent job is running, okay? So that's an important consideration. You may have a situation where you have your parent job doesn't do a whole lot and doesn't need a lot of memory associated to it, but you do have some child jobs that do. And so you can allocate more memory to the child jobs, and have a different JVM spin up for it. And that's something that you would be able to do with the independent process. Another checkbox on here that's important to look at is die on child error. If the child process has an error, do you want the parent job to continue? Okay, or do you want the whole JVM to exit? So if you have this checked, the whole JVM that this is running under will exit, right? So in some cases, you may want to do that. And then we have this other one here, which is transmit whole context. And what that checkbox does is if you have it selected, then all of your context, which is kind of like the input parameters to your job, will get pushed down to the child. Now, with how Java works, right? So it's going to produce a copy of each one of those variables that go into the child job, right? And if you have a lot of context, that could be a lot of copies, of a good amount of data. So you may not want to do that. You actually can uncheck this, and you can be very specific as to which values are going into your child job. There's some other cases too where maybe you want to change the context that's going in. You don't want to actually use the actual context value that you have in the parent job, and you want to use something else, and under the same name, and push it down to the child job. This would be a case where you would uncheck that, and you can modify that context variable. So it's a few important checkboxes to think of when you're using a T-run job.
You're not sure which options to pick from the start. What do you recommend?
Well, I mean, I think it's important to understand, what your job is doing. So if you have a child job that's not doing a whole lot of heavy lifting, or maybe not doing, T-maps with lookups and things that would use a lot of memory that you can probably include it in the current JVM. If you have some really heavy lifting jobs, you may want to consider, checking that box. The die on child error, for example, that's more like flow control. Depending on how you want to exit out, will determine whether or not you want to check that. And the context, it just depends if you have a lot of context, you may want to consider unchecking that, and then being a little more specific about sending only the context that you need for that child job.
Okay, so if you're starting off with a simple job, you may just let it be in the same VM and grow it out from there.
Yeah, you can always change it later. It's easy to change, right? Yep, just checking a few boxes.
So, what's the recommendation on how sub-jobbed your thing do you want to go? Like, do you want to follow all the way down like a microservice architecture setup today, where it's you write everything in its smallest wholly owned component, and then you have one big giant master parent flow job that runs through it all, or is that
probably too low, or too low granularity for that. I wouldn't necessarily go that low. You want to think about reusability. If you can manage to make things reusable, orchestrate kind of where it makes logical sense. I would say, and then there's this other idea of context, right? Of not the context variables, but rather the context of the data that you're working with. And sometimes it makes more sense to keep certain things within a certain job, because you won't have to reload that data or do anything like that, right? So like you may be working with the same data in the same JVM. There are some cases where you would want to keep things in the same job just for the context of it. So I wouldn't recommend going too deep on that, but just do it where it makes logical sense.
Okay.
Mm-hmm. Okay, and yeah, actually here's some recommended nesting is 5, right? So that's you wouldn't want to go past 5. All right, so now we're going to go into some more best practices. These are the new ones that if you haven't, let's see. So if you haven't seen the second part yet, this is all new stuff right here. So so the first best practice of this set is understanding code routines and some of the reusability that you can get by using that. Right. So you're probably familiar with TJava, right? We have a few different code components that allow you to inject Java code right into your jobs. You can also make those a little more reusable, right? So TJava is a component, right? It's inside your job, and anything that you do in there is only in your job. If you want to reuse something, you'll want to pull those out and maybe make them into code routines. And these routines are something that you can create that can be used either, it's almost like a function call that you can create that can be used either in a TJava or a TMap or pretty much any field that you have where you have a Java evaluation, which is most component fields allow that, right? So that can be very useful. You can use this to create logic that very often you're using very often across your projects, and you want to make sure that the logic is always the same. You may want to create some routines for that. You can even make it even more complicated. And let's say you have a password server, and you have some code that they gave you that you want to use to grab a password out of a password server someplace. That code you can put into a code routine if you wanted to, and then you could use that through all your jobs. So there's some things that you can do there, and that can be very useful. As far as the TJava components go, as I said, they're not reusable, right? They are part of the job that you created them with. There are a few different types, right? There's TJava, and then there's TJava Row and TJava Flex. The TJava will execute one time and will, can be used for things like, very often people put system prints or something like that inside of a TJava because they want to print out some information that's going on throughout the job. Which, by the way, I actually recommend probably not doing that and using like a log. We actually have log variables available to you. So instead of doing like systemout.print or system.out.println, you may want to do like log.info, because you can actually have things funnel into the right class of log if you use log.info instead of using just a system.out.print. So that's something you may want to consider doing. Those are some of the things that you may do in a TJava. You can even do more complex transformations if you need to, like if we don't support something. Recently I was doing a conversion from JSON into a dynamic schema. So there's some you can do those with TJava, with a few lines of code. So they can be really useful. Any questions? Feel free. Okay. All right. So best practice 18 here is knowing about the repository schemas. So you can actually create schemas in your metadata repository. So instead of going into each component and doing the built-in schema, built-in being this is where the schema is stored as part of that job, right, or as part of that component, you can actually create these schemas in the metadata so they can be reused across many jobs. And they can also, changes to the schemas that you have can also then be inherited in the other jobs when you make changes to them. So that can also be very useful. There are different types of schemas that you can create. We have some that are specific for certain file types or databases. So we have those. And then you can also create generic. And this generic type can be used just about anywhere, right? It could be used in a REST call. It could be used in a database schema. It could be used almost anywhere throughout Talend. So that can also be very useful because it's very flexible. All right, so best practice number 19. This is Log4j. So all of our components are enabled for Log4j. And what this means is you can set up our Log4j to push our log data someplace, right, using an appender. If you're using the Talend log server, for example, which is an ELK stack, so it's Elasticsearch, Logstash, and Kibana for the front end, right? You can set up an appender for Logstash to push that data into Elasticsearch so that you're able to see all sorts of very interesting and useful log information in a dashboard, right? If you have any other appenders, or let's say you have some other log collecting applications in your organization, and they have Log4j appenders, you can configure them here, right? Again, with the log info, you can use either twarn or tdie. These will create the correct classes for you, or whatever you select inside the twarn, for example, or tassert, right? Or if you're doing like the tjava, like I said, you can use the log info, log warn, log fatal, whatever you need to do there, and it'll all get filtered into the right class. You can also enable it on attack. So it's not only something, the previous screen was showing you how to basically set it up on the server. Let me actually see, 1 second here. Let me blow this up real quick. Yeah. This is on the studio side. I think this could be useful to go through. Of course, on the wrong screen. OK. So this is on the studio side, and basically, if you go into your project settings for Log4j, you'll find a Log4j setting there, and you can activate it here, and you can add the appender. So here's an example here of the Logstash appender, and this is where you're basically saying, this is we're going to take all these logs and we're going to put it someplace, right? And so it's going to use this appender. So this is going to point to your Logstash ELK services, right? So it's really easy to do. All right. And then on the TAC side, you can basically do a very similar thing. You can enable this on the TAC. And some environments you may want to have more detail enabled than others. You may want to show, so this is the log level here. That's all that is. You can set the minimum log level that you're going to see from the logs. And it could be info, debug, warning, whatever. And in dev, you may want to see more debug information than if you were in production, right? So you may want to set each TAC appropriately. And that's something you can do inside your job conductor. If you're sure to use these tdie and twarn and tassert, then again, all of those will flow through into your log properly, and you'll see the correct class of error coming out in your log. All right, so activity monitoring console. Has anyone used activity monitoring console, AMC? Yeah, it's overlooked a lot, so it's actually really useful. You've used it? Oh, sure. Go ahead.
You said obviously tdie and twarn are obvious. What would the tassert be used for?
So you can check to make sure certain values are what you expect them to be.
Oh.
Yeah, yeah. So or fail. So yeah. Okay, so this is the activity monitoring console. And this is often overlooked, but it's very useful. This is basically some stats collections that can show you what's going on inside your job at some pretty good detail. So you have, you have the log table, and I'll blow this one up too. 1 second. I wish they all opened up on the right side here. There we go. Well, a little better. So there are basically 3 tables involved here. You have a stats catcher, a log table, right, for the log catcher, and the meter for the flow, right? So the log is pretty obvious. It's whatever log data came out of your job can get logged and stored into a database. The stats will tell you how many rows are being processed and timing of each one of your components and things like that, right? So you can say how much time was spent processing in the input component or in the T-map or what have you. That can be very useful for kind of understanding where your bottlenecks are, right? And then the flow will tell you exactly how many rows are going through between each of these components. So like an aggregation, for example, may have a million rows going in and a few thousand rows going out, right? So that can be also very useful information. So once you've set up these tables and you've included these monitoring components, let's see if I can flip back. There we go. Then you'll be able to, in your studio, you'll be able to actually see in one of the perspectives things like a pie chart and or a list of the log information and how much time was being spent in each one of your components and what the flow was. Let's see if so this so this is actually the studio here, even though we're talking about TAC over here, but this is what the studio looks like in that perspective, in the AMC perspective. And so you'll see. Yep. Sure. Go ahead.
So that visualization is actually available in both.
It is. That was getting there. Yep.
Mm-hmm.
Yep. Mm-hmm. So this is the studio view, and so this is an example of the pie chart and showing you how much time was being spent in which components, and then you can see some log information, the log events that occurred. So if you're creating good error codes, for example, you'll be able to see the exact error code that occurred and what was going on at the time and what the message was. So there's all sorts of really useful information that you can get using the AMC. So we have some documentation on how to use the AMC. It's not too difficult really. It's really a matter of creating those tables for the first time so that you have them out there and you have some place that it can be collected to, and then you configure on the studio side where that's going. So, and as Dale had just mentioned, in TAC, you also have the same visualization available to you. So, so it's not just something that you'll see only in your studio, but also on the TAC side, you can point it at the database and you can actually see what's going on and see pretty much the exact same view. How much time is being spent, in the job doing what, right? All right, so we got recovery checkpoints. So this is another feature that I think is overlooked, and it's basically when you have a job that fails, how do you recover that job? How do you start that job from where it left off, right? And so we have this concept of recovery checkpoints, and basically what it is on these on-sub-job OKs that you see, and I'll blow this up again here. So we can. Can't see my cursor. Okay, so you see here, so we have a subjob here, and then we have an on subjob OK, and then we have which is doing an input. It's maybe doing some type of modification in a Java row, and then it's doing an output into MySQL. And then there's an on subjob OK that's putting out a log warning, and then another on subjob OK that's going to do the next step in the process, which is updating the user records. As you can see, it's kind of documented right within the in the job itself. So this on subjob OK. So anytime you have an on subjob OK trigger, you can set that to be having a recovery checkpoint. So if you've passed that point, then successfully, then that point can be recovered up to that point, right? So when you're building your jobs, you want to make sure that you build the sections between your checkpoints as kind of self-contained in some way. committing your transactions, things like that. Make sure that, if you do need to recover, that you actually can recover, and that any failure, comes back to that same point. Something else also to note is you can put failure instructions here. So in some cases, you may have a failure after a certain point, and it may require some cleanup. You may have to, clean up some tables because maybe there's some situations where maybe you have to commit, like for example, you have something that's committing every 10,000 lines, because you're trying to avoid your archive logs becoming too large, right, or something like that. So in that case, though, if it does fail, there have been some commits. You may want to have an instruction that says you need to run, some command to back it out. These instructions that you put here will actually show up on the tax side. And so I'll show you a picture of the tax side, what this looks like. So when you're going to do the recovery, so let's say you have a failure, okay, you can click on it in the error recovery management in your job conductor, and you can basically say recover task, okay, and that will continue that task where it left off from the last checkpoint. You'll also see a message pop up for what to do. That message that you put in on that checkpoint, for what to do, to do that recovery. So that if there's any manual steps involved, that's what you'll do. If you need to, you can also reset the task to, bring it back to where it should be, or restart it from scratch, right?
So you can pick up some task that maybe is completed and go back to pick up from the task even if it has completed. It doesn't have to fail for you to pick up.
It has to fail in order, well, let's see. Yeah, it would have to fail in order for you to get to this point because you have to go to the recovery area. So it would have to be a failure, but once it's successfully passed a checkpoint, then in the failure recovery, you can then say, start it back off from there.
So the scenarios you've got a really long running job. Let's say it takes 3 days to
Yep.
get through all the steps for whatever reason.
Yeah.
And it's all successful based on what I knew at the time, but I realized, whoops, I really want to do something different. I don't necessarily want to start from the first step and wait 3 more days to figure out if my change at the tail end of the pipeline is finished. Can I pick up somewhere in the middle even though it succeeded the first time?
I actually don't think you can. Yeah, I don't think you can.
It's an interesting scenario.
Yeah,
too.
it is.
And this really goes to stateless operations,
Yeah.
orchestrations. So what I recommend in that is to create a state entity, right? And even if you complete the state, you can know how to reset or restart your jobs from that particular state. And you write your jobs to check which state you want to start from. So you usually have a table of some sort that you can read and drive your stateless engine that way.
Okay.
This is a recovery, so it implies that something failed.
Sure.
Yeah. Okay. Go ahead.
Go back to this one. I just wanted to see the recovery options we see.
Mhm. Yeah, so these are the same options here. Yeah. Okay. Good. Okay. All right. Go ahead.
When we have a scheduled job, which runs every 3 hours or 6 hours once, one of the cycle got failed. So when the time comes for the next cycle, so what are we to do? So we'll start executing that or it will wait?
Can you repeat the question?
Yeah, so the question is if you have a job that's scheduled to run every 3 hours and one of them fails, what's going to happen on the next iteration when the schedule comes up? Is that your question?
Yeah.
Yeah, and I'm actually not sure, but I think it'll actually execute. You'll execute? Yeah, okay.
Just because an execution failed, doesn't mean the next time it's triggered to execute, it will stop running. Depends on how you orchestrate it. If you're using an execution plan or not, things like that.
Okay. There we go. All right, so now joblets, right? One very common usage for the joblets are to create some type of log catcher, so you can manage. You'll be listening for logs, and you may be processing them a certain way, right? If you get a fatal, or an error, then you may want to send an email someplace, or if you have a warning or whatever, you may want to log it a certain way or put it into a certain file someplace that triggers maybe a monitoring software or something like that you have set up. So, you can create a joblet that you can then include in every single job, right? And that's something that we actually talk about in the first set of best practices. So I'm just kind of going through this here. And that kind of looks like this. So you have a log catcher, which is basically like a listener, for all logs. And then you have, how you're going to process those, right? And you're going to say, if it's a debug, you're going to go down this path. If it's a info, you'll go down the second path here, or warning and what have you. And you'll decide on how you want to handle those errors, right? So that's a common usage of a joblet. And the reason why you would use a joblet in this case is because of the context. You want to make sure that the log catcher is listening in your current job, right? If you tried to do this in a T-run job, that may not work out too well, especially if you use an independent process, right? It won't know about anything that's occurring in the parent job. So this is a really good case of a joblet, because you want to keep it within the context of the job that you're currently running. So that's one use of a joblet. But you can also use joblets a different way, right? You have inputs and outputs. You don't have to always use the inputs. You don't have to use the outputs. But you may want to in certain circumstances. And basically, you're allowed to take in a schema, and you're allowed to do some processing on that data. And you can optionally send that data on to another part of your process. And you can create a joblet that does that, which then you can use inside any of your jobs. And joblets are a little different than child jobs because they're actually included code, right? T-run job is for running a child job. A joblet is something that will include that code inside the job that you're including it in. Instead of a call out, it's included, right? So the reason why that's also important is because if you're using the same joblet repeatedly throughout your job, it actually will be a copy of that code within your job multiple times. So that's really how that works. But it can be very useful in certain circumstances. If you have certain transformations that you do repeatedly, you could encapsulate that inside of a joblet. That may be one case of doing that. You may have certain transformations that you do, and you want to consider a joblet to be like an input component, but you want to do something special with the data that's coming before sending it on. You could create, and you always do it, or you do it very often in many jobs. That's something that you could put inside of a joblet, and you wouldn't need an input for that case. You would need an output, and you would just have your input and your transformation, and then you would just send it on the output, and then that would be kind of like an input component. So that's something that you can do also with joblets. The whole idea is reusability, right? Test cases. So if you're doing, especially if you're doing CI/CD, test cases are very highly recommended in CI/CD environments, right? This is where we can within Studio create a test case around one or more components. And what this allows you to do is make sure that these components are behaving the way you expect them to, and maybe the way that you have requirements set to. So like you may have certain transformations that you do, and you want to make sure that you don't mess those transformations up, or certain aggregations that you do. And you want to make sure that those aggregations aren't messed up because you have requirements that say, this is how it should work. And so based on those requirements, you may want to create some test cases. So with these test cases, you can identify specific components, and you can actually generate this test case. So you right-click on your components, and or you can highlight one or more components, and you right-click and say, create test case. It's fairly simple, and it will kind of make that part of your job a joblet that then gets used for test cases. Let's see. Looking for the other screen. Here we go. So once you've created that joblet, or that test case, this is what it ends up looking like. And you can see the component that was highlighted gets included here. And it has kind of an input and output, just like that joblet I mentioned to you. Anytime you make a change to your primary job, that change will then get reflected in the test case. So it can be tested. right? And then you'll have these. You'll see this framework that gets built around your job, around your component. Okay, this is the test framework. And you can modify these as needed. So if you have input files that are generated somewhere that you want to include here, you don't necessarily have to follow the defaults, which is semicolon delimited, files or whatever. You can actually take these out and replace them with something, or change the delimiter, or whatever you need to, right? So you can modify these test cases as needed. But the whole idea here is you're going to read a file that has your input. You're going to run it through the set of components that you have defined that you want to run the test case on. And then you want to compare the output of that to some known good file and make sure they match. If they match, you're good. If they don't, then you're not so good. And you need to go figure out what happened. Could be that the developer messed it up. Could be that the requirements changed and you forgot to change the test case, right? Could be any of those. The idea here, though, is, especially if you're in CI/CD, because you'll want to do these unit tests every time you do a CI/CD build, right? So if you have Jenkins set up, for example, and you have it set to detect changes on a certain branch and to build and test and deploy, these tests will automatically get executed that you create within Studio. These tests will automatically get executed as part of that process before it allows it to deploy. So that can be very useful kind of unit test of certain components that you have. So you can also set up multiple files. You can have like different types of test cases that you want to test. Different good data, bad data, ugly data, what have you. One thing I don't really recommend is, like when we say small, medium, large, I don't think we're really talking like large files, because it's more about the fields. Like you may have certain fields that are large, certain fields that are small. Be careful with large files here, because these files actually do get included in your workspace, and which means it will get synced to Git, or your source code repository. So if you put a 1 gig file, if you set this up to be a 1 gig file, that will get copied to your workspace, that will get committed to your Git repository, and that will use up a bunch of space and slow you down a little bit. Any questions about test cases? Okay. All right, so this is about iteration, and so we have some components that allow you to go change between data flows and iterations. So when you think of data flows, you think of a data pipeline, right? Data moving through the components, and work is happening at each of the components somewhat in parallel when you think about it, right? Iterations are a little different. It's more like a call. Okay, so when you iterate on a set of components, it's like calling that set of components repeatedly, right? There are certain cases where you want to do that, and certain cases where you have to do that. One example would be, let's say you have data coming from a database that you want to call repeatedly against a REST service. You won't really be able to do that directly from a data flow, but you can do that from an iterator. So what you'll do is you'll do your query to get the information that you need, and then you will change that data flow to an iterate, and then link that to like a TREST component. And then for each one of those that get iterated, it will call that TREST component, and you can access the data variables that were originally in the data flow. These iterate components, we'll put them in the global map so you're able to access those values at each iteration. So that can be something that's very useful in certain circumstances. So it's good to know that they exist and when you might use them. All right, so best practice 25 is about TMAP. Everyone uses TMAP pretty often. It's probably the most often used component, right? So with TMAPs, you'll do very often you'll do joins. There's different ways of doing joins, and this is really all about understanding those different ways of doing joins and making sure that you're choosing the right one for the right situation. So with these joins, you can either read a lookup. So you'll see that a TMAP has a couple lines going in, right? So you have your mainline data flow going into the TMAP, and then you'll have like a lookup, okay? Now this is important because that lookup is really what we're talking about, is how we do that lookup. The default will be read it all into memory, okay? So it'll just read whatever query you have set up over here, or whatever table you have set up over here. It'll read the entire thing into memory, and it'll do the join at the TMAP. That's the default. Then there are some other lookup models that you may want to implement. There is the lookup for each row. So for every row that comes in on that main line, it will execute a query to pull that row. And then there is the same thing except for caching the results. So as you encounter new values in your lookup from that point query, you will cache that in memory. So you think about the different situations that you might have, right? You have a small lookup table, pull it all into memory, right? You have a lookup table where very often you're going to maybe cluster on certain values out of that lookup table based on the run that you have. That might be a really good situation for, and it's a large table, that might be a good situation for reading row by row with caching, right? Single row with caching. Or if it's going to be all over the board and you're likely not to get any benefit out of the cache, then you don't want to waste the memory, right? Because you have a very large lookup table that you don't want to bring into memory. In that case, you don't want to use cache. So you have to think a little bit about the joins that you're doing and which lookup type you decide to use.
Is the cache a fixed size?
It's just heap. So it's just your heap size. So it's whatever you set for your memory for your process.
So you can run out of, if you allow it to grow, it could eventually run out.
That's right. Yeah, you can run out of memory. And that's just the parameters, the Java JVM parameters for the XM, the -x, XMX.
This is
Yeah,
often RFU cache, that kind of thing. It's literally a heap.
yeah, literally just heap. Yep. So this is where you find that lookup model. So load once, load once. Looking for it. Yeah, I see it, but okay. So we have the lookup model here, and then we have the match model and the join model. That's actually what it's highlighting over here.
Yeah, there's another slide.
Oh.
I'd also consider the fact that if you can load everything into memory, your operation of your join is going to be much faster. As opposed to, well, it's too much data to load into memory, so let's do it row by row, which means you're going to be able to process it,
Right.
and it's going to take up no memory. So it's a trade-off, right? You got to make a judgment call.
So is there a third option? At what point would you say, push this down to the database or the Hadoop cluster?
Yep.
Right?
Push down is a different conversation, right? And it involves ELT. This isn't an ELT component.
Okay.
So
Right.
this is a straight data.
Well, right, but when I'm designing this, right, I would either choose this or I could choose.
You could choose an ELT component,
Yep.
or you could choose other push-down technologies. That's not this component.
Right. Right. Yeah, there's a set of ELT components that you can use, ELT map and ELT inputs. And it would be a very similar setup, except you wouldn't have these lookup models because everything would be pushed down.
You just
Yeah.
instruct the SQL query, and it passes that down to the service hosting, push down, and away it goes.
Yeah. Yeah, or the ELT components will also build the SQL for you as well. So.
Is there a benchmark number that you choose, that you could use?
Yeah, that's something that's very specific probably to your database and your situation. You may have indexes a certain way. There's no like general benchmark that I could give you. It really depends on your situation.
So there's another question over here about lots of lookups. And yeah, you can connect many larger.
Larger.
Yeah, so size and shape of data is always an important consideration. TMAP can handle many lookups. Some of them might be loaded in memory, some of them you might process row by row, some you might add cache. Depends on your use case, right? It's all about what data it is you're processing.
Do you suggest for like the larger, like, table size, 1 million, 2 million, the short size?
1 to 2 million, 10 million rows, you can, if just have enough memory to load it into.
Yeah.
Right, so size and shape of data is important. If you're gonna run it on a job server that only has 8 gigs and you need 20, obviously you don't wanna do that. If you're limited to the 8 gigs, then you have to change your job design.
Yep.
If you can throw more memory on your job server, then who cares? Load it all into memory, you'll get faster performance. It still has to load the memory, so if those 2 or 10 million rows, you only need 10 or 20 or 1,000, why load everything? That's gonna take time as well. So you have to find a balance, striking a balance. It's understanding your use case, understanding the size and shape of data.
Right.
What is the lookup doing? If you use the load once, the default, it will load up all your lookups first, and then start processing your data. If you do the reload at each row, it will start processing your data and do the lookup, one by one, row by row. So it's a trade-off, performance versus scalability, memory management. And Mike, you're going to talk about how to hook that up, right?
Yeah, that's next. Yeah. Right. Yep. And so, as I mentioned, you'll have to do point queries, right, for these row by row lookups. And so the next question is, well, how do I define what those point queries are? And that's what we'll talk about next. So on your lookup.
Can you go back to that previous slide? It's circled in red there, but that's half of the battle right there. When you set and reload each row, you've got to create global keys.
Yeah.
Okay, that gives you a memory variable in the global stack that will store the current value of the row of the key. Current key's value. In this case, there's 2. Right? And then they get saved in the global variable, row at a time, so that on the next slide, with your lookup query, you can actually grab those values with the global map.get method to create a where clause. Get me the row based on this key. Of course, that where clause should produce a single row. That's your best case scenario. So you probably want this to be based on your primary key. Hopefully you're managing duplicates properly in your database model, but some people don't. In which case, your first row will come through and get duplicates. So be careful.
Right. So right, and so this, what you're seeing here is the lookup query, right? So this is as part of the TMAP, it is that lookup component that you have, it's that MySQL input component that's coming in as a lookup on that TMAP, and so we're defining that where clause, as you mentioned, as the expressions that you see. Looking. Okay. Yeah, I don't know where it is. So anyway, so these are defined, though, inside your TMAP and as expressions, right? And that's actually how you get these global variables that you see here. So that's something that you'll define inside your TMAP under expressions.
So your TMAP defines them, your query uses them. Without those 2 pieces, it won't work.
Right. Exactly. And as far as the caching goes, that's all handled behind the scenes. So if you have it selected with caching, it will automatically throw into a map and a hash map or something and look it up as needed. So, any questions about this? No?
I was just going to say, just to comment, one of the best practices I do, especially when it comes to TMAP and reading files, is especially when you're trying to get it all into memory, is using the T-column filter. That way, eliminate anything that you're not needing, especially when it's going into memory.
Yeah, it's a very good point.
One of the best practices I learned on Talend, one of the Talend websites, I'm sure I found something on at one point. But
Yeah, definitely. Yeah, excellent point. Yeah, don't bring in more columns than you need, right? So if you're joining on 2 columns and you have one column that you're looking up, you should have 3 columns probably in your input component.
Where generic schemas come into play.
Yeah, that would be very useful. Yeah. Very good point. All right, so next we'll talk about global variables. There's a few different types of global variables. You have your context variables, which you consider to be kind of input parameters into your jobs, right? Or if you have if you're calling a T-run job, you may be sending some context in to that run job, and it's usually used to direct how your job is going to run. Don't really recommend using context variables as something that you're going to change within the job itself. We have different ways of doing that, and that's what we'll talk about here. You can actually set some global variables. And these variables get put onto what's called a global map. And so as you put things onto the global variable list, you can then reuse them throughout your job. They can also be used in a thread-safe way. So when you're doing threading, copies of the global map are actually created for the threads. And so if you're doing parallelization, the global map is considered to be safe from that perspective. So global variables can be pretty useful. You may want to, like an example is, you may want to say, I want to retrieve the last date that I processed data. So give me the max inserted date on a table. And then I want to use that to, so from the target system, I'm going to say, give me the max date. And then on the source system, I'm going to say, okay, now give me everything greater than that date. Two different systems, two different connections, right, that you may have. You want to store that someplace, so it can be used in that second query. That's where a global variable comes into account. So they're pretty easy to do. You can just define the global variable. So you may have a query that's pulling some values, and you're going to send that as a data flow into your set global variable, and you'll just map that field on the data flow to a specific variable name, and it will just assign it. So then it can be used later, right? And use it, the way you use it, sorry, I'll go back here. You may not be able to see it too well, but it's basically just accessing the global map. In the editor, you can do a little shortcut and hit control space, and you actually are able to see the global variables that you have defined in there, which can be kind of useful. That's one way that you may be able to do it. So you can, so if you've defined it using the component, it actually is available in that list of possible completion, the autocomplete, a part of that editor. So that can be useful. But otherwise, really, it's just accessing the global map and doing a get using the same variable name that you use in your set global variable, set global var component. We also have the same thing available for big data jobs. They're named slightly different, but you'll find them named T global var load. And so you can load global variables for big data usage. And it's used in a very similar way. We have a global map, and you're doing a cast for your data type, calling the get on the global map for whatever variable that you happen to create. And then, so there's this outline. So I'm not sure if everyone has noticed on the side, on the left side of your screen, you have an outline, and that outline can be pretty useful. For each component that you add to your job, you will have an entry in the outline. And you will see under that a list of all the global variables that you have available to you that might be useful. And you can think of things like when you're doing audit balance control process or something like that, and you want to get the number of lines that you processed. You don't really want to count every row that goes through the system just so you can get a count of how many things processed through that line or through that component. Instead, you can just say, well, when that's finished, how many rows did you process? You can ask the component almost, in a way, right? It's saved in a variable for that component. That's something you'll find here in this outline. So this outline can be very useful. You can also see things like what's the error code. It'll actually also tell you, and it's a little small, but it says after, right? It may say after, before. And what this means is, when is this variable available for use? Some variables are created and populated after it's completed, right? So once that component is complete, it will be available to you. Some are available before. Some are available during the process, so you can see what's going on at any given time and use that variable. So like an iterator, for example, would have those, right? So that outline is very useful for accessing quickly that list of global variables. There's also a couple extra global variables that aren't listed there that you might want to use if you're doing any kind of logging or auto balance and control. You may want to say what's the job name that that I was running, and you don't want to hard code the job name because it may change or what have you, or maybe you're doing a template of some sort that you want to reuse later or copy that job. You can access this global project name and global job name. And so that can also be useful. Those are some useful strings that you can include for various reasons.
Is there a variable that includes like the total runtime of the overall job?
Total runtime of the job. That's something that's, you can find that in the tax side. You can find it on, for the execution itself. But, or if you're doing AMC, you'll find that. But yeah.
Start and end
Yeah.
for the complete.
In your logging,
Yeah.
you're going to capture that. And then the console display, the execution. Sysout has it.
Yeah.
It always has the start time and the end time of the job.
Yeah. If
How you're capturing your logs. That's really something the AMC is really good at.
Now, if you really want to create those variables, you can do it yourself pretty easily. I mean, you can do a set global var, and you can use just a Java, get time type thing, and put that in to a global variable at the start and do it at the end. So there's pretty easy ways of doing it yourself too, if you want to.
Yeah, I was thinking about checking the runtime in the middle of the job somewhere to see how things are progressing.
Well, so these things are available within your job. So yeah, from externally coming in, you wouldn't really be able to do it. It'd be more about the logging, like where you're putting your logs and being able to monitor those logs and monitor the running of your job that way. Yeah. So.
Just wanted to ask that, if you're iterating with the file list and then we are after processing each and every file, I want to print the number of lines. So that would go, because it will complete after I process that file, right?
So it depends on it. So the question, and tell me if I understand it properly. The question is when you're using like a T file list and you're iterating through the list of files and you're processing them, you want to see what the number of rows that you process during that. Yeah. So and that is available. You actually can access that. It's not at the end of the job. It's at the end of the usage of that particular component. Yeah. Yeah. So that actually can be done.
On sub-Java OK, at the end, will come right off the T file list. Like if you do a T-Java, and you can print line, it's going to be your object name dot NV underscore line.
And another possibility would be also to use it on component OK in certain cases. So after the component has completed, you may be able to access the variable. So if you strategically put the on component OK, because I think I understand what you're saying. It's basically you have a subjob that's iterating on the file list, but when you're iterating like that, you're actually going to have two separate subjobs. So really the subjob OK probably should work, but there's some other cases where you could possibly use an on component OK to get around that, because once that has completed, it actually means the previous cycle had finished, and therefore that variable will be available to you. So there may be some things.
Cycles of iteration, auto iteration,
Right.
file itself.
Yeah. Right. Exactly. Yeah.
It's a nested
Yeah.
section, like two separate processes.
Okay. Okay. All right. So loading context. So this is a good one. So with context, you can have context groups, and you may have different environments, right? Your dev, test, and prod, and that's great. Except some folks don't want to actually put their production passwords into a production context group that everyone gets to see, right? So you actually don't have to use the context groups in that way. You can load the context from basically anywhere. It could be a file. It could be a database or whatever we have connectivity to, right? So we have a tcontext load component, and any data that you have coming in get mapped right into your context variables, right? And we also have a dump, a tcontext dump which will basically take all the context variables that you have and write them out, basically put a data flow out. So if you, for example, use a database to store all of your context into a table someplace, you can do the t-context dump to push it out to the table, and you can do the t-context load within your job later to load those context variables in. So if you have passwords or whatever. One strategy, for example, might be to keep a context file on every job server. So in your dev environment, you have a kind of a lockdown file someplace. And if you're using password types, then it gets encrypted on disk, right? So you may have this file sitting someplace that you're expecting to see it for all your jobs. And this is where you can get certain context, like how to log into a database or what have you. And then every environment can have its own context file that you can load with the appropriate environment information. Where to connect to, what the username should be, what the password should be, things like that, right? And so those are some components that help you in a very flexible way manage your context variables without having to necessarily use the context groups. All right, then we have dynamic schemas. And so this is a fun one if you're doing a lot of the same things over and over again with data, different data, right? So let's say you have 100 different tables that you need to load, and you're loading them all the exact same way. It's just you have different data coming in, and they all load into different tables. You could write 100 jobs to do that, right? Or you could write a more intelligent, more like a framework type job. And really, that's what this is about. Instead of writing 100 different jobs, one for each table, you write basically what the framework is. You say, I want to read it from a file, whatever it is. I want to maybe do some type of small processing, and then I want to load it into a table someplace, whatever table that should be, right? Whatever schema that should be. And so instead of doing it in 100 jobs, you can do it in just a couple jobs, right? One job to just dump out the metadata for the schema, and another job which is really just going to load that schema up so that you can use it in your processing. So this is using something called dynamic schema, and many of our components do support this, and it's basically a way of not having to define the exact schema that you're doing at runtime. So instead, you can load that schema up, and when you connect to, when you have your file component, for example, reading using that schema, it will use whatever dynamic schema that was not defined at the time that you designed it, but at the from the metadata itself, can then load that data up and then do whatever processing, and then even target a certain table, right? And the table can also have dynamic schema as well, saying what are the field names and what's the table name that this is going into. So it's a way of writing a single job that's going to be more of a framework, right? So where do you get that metadata from? And the answer is you probably get it from your information schema, right? That's going to be, every database almost has some way of querying a list of what all the columns are, what all the data types are, things like that. That's where you're going to get this information from. So you can read from, like for example, Oracle all tables, for a specific table. And you can say, give me a list of all the columns, and go ahead and load that into my dynamic schema using this tset dynamic schema. And then you can reference that schema later, right? So the other thing is, instead of using the information schema and writing those queries by hand, you can actually use some of them that are built into Talend. Talend has, so you'll find this table list and table column components. And that's basically going to query the information schema for you using whatever facilities are within JDBC. So it's kind of defined inside JDBC. So that's really what this is going to do for you. So if you're going into MySQL, you don't have to go find out what the information schema is for MySQL and how to query it and make sure you do that correctly. Instead, you can just use tMySQL column list, and you can put the parameters in that you need for the table that you're looking for, and you can get all the information you need for, sorry?
I was just giving you a time update.
Oh, okay, I got you. Okay, sorry.
There's two subtleties here that
Mhm.
I'm going to call out.
Okay.
One is on these two components, right?
Mhm.
There's pair for most of our databases. It's easier to code, right? Compared to actually having to write your own query for the information schema and get your table list and then get your column list based on the table. A little harder to write, but here you can't affect any transition with the T-set dynamic schema. When you use your own query, you can change the data type or truncate a column value. There's some minor transformations right there as you dump out the data. Whereas with these components, you can't. So
Right.
a little bit of a trade-off. You get a little more power when you spend a little more time writing it yourself, or you can just do it the easy way and use these components and you're good to go.
These two don't exist for Teradata, right?
Sorry?
The table list and column list, it doesn't exist for Teradata in 6.4?
No. Teradata is probably not one of the ones on the list. Or Netezza or those kinds, and they're big, there's nothing like this for Hadoop or Hive.
Yeah.
Oracle, MySQL, Postgres,
Yep.
Microsoft, all of the major relational database vendors.
Yeah, basically, if you don't see your database here, it's in this format, right? So it's oops, sorry. It's in this format, T, and then whatever the database is, table list, and if you don't see it there, then you'll have to go look up the schema yourself, and you'll have to just do a query instead. So, yep.
The other point I should call out is the file, the dump file,
Mhm.
is a fixed length positional file. Right? It has to be fixed length because it doesn't know the schema until runtime. So you can't use a comment limited file, or you have to use fixed length. No big deal.
And loading has to be generic, you cannot put any transformation.
Well, no, yes, you can, because the loading is just the opposite logic. You still get the schema, you figure out what the schema is, you set it at runtime, and then you read the file. Whatever you do with that file before you actually put it into your table is up to you. It's just a load. It reads the file because it's got the schema now, and then what you do with it downstream before it actually arrives in your table, a target table, is up to you. Put a T-map, do some lookups, merge it with some other tables, whatever you need to do.
All right.
It's like Mike said, it's not a framework, building a framework. It's very cool.
Okay. All right. So change data capture. So you may not know we actually have CDC components built into Talend. We support a bunch of different databases, as you see here. Oracle, MySQL, SQL Server, Postgres, a whole bunch. It's basically like a publish-subscribe mechanism. As data changes in your table, we're going to, depending on which database you have, we're going to either use a trigger to log those changes to another table, or use archive logs or streaming or what have you if you're using Oracle. This can be very useful. It's a very common use case where you just want to keep two things in sync, two tables in sync across two different databases, right? And you'll see, I'm sorry.
Was this comprehensive? This is all the supported?
Yeah, I believe this is what's supported, yeah. The question, I'm sorry, is are these all the ones that are supported? These are all the ones that I know about, but I may not have looked at the most recent version of Talend. Yeah, so I'm not sure. I haven't looked at 7.1 to see if any new ones have been added. So, but you'll know which ones are there because you'll look for TDB CDC. So if you do go into the palette and type a search for CDC, you'll see a list of all the CDC components, right?
Again, you're not going to find Hive or Hadoop or
Yeah, right, yeah.
Cassandra or Mongo. These kinds of things don't have the concept.
Right, right.
So we're not going to be supporting.
And if you think about how the CDC is implemented, which we'll see on the next slide here, basically our CDC is implemented one of three different ways, depending on what database you have, right? If you're using Oracle, if it's 11G or earlier, then we'll do the redo in the archive logs, okay? If it's Oracle 12, then we'll do the extreme. Everything else is going to be trigger-based, right? So, so at the very least, the database would have to have triggers before we could even consider doing a CDC based on the method that we're using here. So you won't find those things in like Hive or Cassandra or what have you. But you'll find them in many other databases. There's a whole guide on how to do this. So if you're looking to do CDC, definitely check out the guide. If you go to help.talend.com, under if you do a search for the CDC, you'll find it's basically, it's fairly easy to find. Literally just type the word CDC in help.talend.com. It's one of the first items that come up. CDC user guide, and it'll be probably the first item. So it's very useful. But as I mentioned, so for many of the databases, it's basically a trigger that's added to a table. It's going to look for inserts, updates, or deletes. And it's going to, every time this occurs, it's going to push this out to another table, which then the CDC component is coded to specifically understand how to process. And that way you can read in the change, and it'll also apply the change to the target. All right, so we have over 1,000 components built into Studio, but in the event that you find something or don't find what you're looking for, you may want to start looking at third-party components, right? We have an exchange. It's exchange.talend.com. There's a lot of components out there that folks have developed and put out there. One example would be Google Analytics. We don't have a component that directly talks to Google Analytics and gets data. Sure, you might be able to use a REST API or something like that with the REST component, but somebody has actually created components specifically for getting that data. And so that could be very useful for you if you're doing that type of work. It's pretty easy to do, to use these third-party components. What you do is if you go into your preferences under Talend, that's under Window Preferences, Talend, and then Components, you can set where you want these components to be installed. So that's one thing that you have to do before you can use these. And then, and I think it's on the next, there we go. And then there is an Exchange link at the top of your Studio, and you can click that. And that will actually bring up a window and allow you to search for various components that are out on the Exchange. You can do it right through Studio. And in fact, all you have to do is click the Install button over here, and it will go ahead and download it and install it into your components directory that you've defined. It will then be available to you under a custom component section of your palette. And you can bring it in, you can use it. You can also create your own components. Let's see, yep. You can build your own. We actually, so this is actually deprecated in version 7. So we actually have a new component kit, which there's a lot of really good documentation on. It was at one point called TComp, so you may have heard of it being called that. But it's actually, the official name is the Talend Component Kit. And the new component kit is a more object-oriented Java method of creating these components, whereas the older framework that we were using for a very long time was a JavaJet framework, and it's basically a template system. You can still find some of the templates, like the Exchange right now, I think, only has the template versions of the components. Very soon this year, they're planning on adding the ability to post the new Talend Component Kit components out to Exchange. So that is coming soon. There are some really good guides for walking you through how to create your own component using the Talend Component Kit. In fact, if you go to help.talend.com, it's right on the front page. Like, you don't even have to go anywhere. You don't have to search for anything. It's literally in the lower right-hand quadrant. There's a series of links there that are just all about creating components. And there's a tutorial that you can walk through creating your first component. How to set up your environment is all there. How to do the builds, how to install that component into your Studio. Everything is very well defined there. We also have a webinar that walks you through that as well. So if that's something you're interested in, just reach out, and we can get that webinar information over to you, and you can start building your own components, right? And then eventually.
Mike is one of our resident experts at building components on our team, so he's the guy to talk to about it.
So is this custom components going to be part of when we export a job? Is it going to be part of it, or?
Yeah, so when you do the build on the component, it's actually going to create like a jar file. It's very similar, and it's going to allow you to post it into the third-party area of your.
It is going to be only on the build, right? It's not on the exporting of the job. It's not going to be.
On the export of the job, it won't be on the export of the job, no, but it will be if you If you publish it to Nexus, though, it will go along with it, right? So, yeah, it'll get put in the third party.
And it plugs into Eclipse.
Yeah.
Right, so it's part of your development environment, not your job. Right? It's creating a component, adding it to the palette, show up on this
Yeah.
plugins, because you added it as a plugin. And you can include it in any job. And any job that you build that needs it will export as a package when you do your build in your CI/CD. So that jar file is included.
Yeah.
But if you think of it and treat it as a separate piece of code that you build and develop yourself, manage yourself, you build it with Talend Studio and this component framework.
Yep. And I mean, you can literally build any component. In fact, every component that we have is either going to be the JavaJet framework or it's going to be the new Talend Component Kit. Many of the new, in fact, all of the new components that we're creating are all Talend Component Kit. And they're available in GitHub. If you go to GitHub /Talend under components, the components repository, you will find a whole list of actual implementations of components that you can use as a starting point if you want to do something relatively complex, something a little, more than just a few things off the tutorial, right? If you want to do something that's difficult.
Input component, fork it, and you add your own special key to it, create your own component,
Yep.
plug it into your environment, you've now created something special that nobody else has.
Yep.
Does, so you said that this is changing when you, in Talend 7, but is custom components built in 6, or just do they
So
go to 7, or do you have to rewrite them and rebuild them?
They'll actually still work. The JavaJet will still work right now. The components themselves have not been deprecated. We still do the code generation using the templates just fine. What is deprecated, however, is the component designer. And that's actually what you're looking at right over here, this window here, and that's why I'm bringing it up. This is actually the component designer, and in version 6, you'll find the component designer. In version 7, when you actually will, in version 6.5 and 6.4, I believe it was marked as deprecated, actually, even when you went to the component designer. I don't believe it's actually available in version 7 at all. But if you go to, as I mentioned, the user guides, they'll actually walk you through how to set up an environment. And it's basically just downloading IntelliJ, and it's installing certain plugins for IntelliJ that will allow you to generate the framework for a component very easily and quickly. So you literally will go in there and you'll checkbox a few things that says how you plan on using this component. Is this an input component? Is this an output component? Is it both, right? Does it just have data that goes through it? And you mark all those things, and it will generate like a base component for you that does nothing that you can just go in and modify. And so that's all defined very clearly in that documentation. It's worth going through if you're interested. It's not that hard to create a component now. You just got to get the environment set up first, and then you go through the first tutorial on how to create that component and do something with that, and yeah, you can see how to do it. It's not too hard. And as I said, later this year, the plan is to allow these components in exchange. That is something that's being worked on. So hopefully we'll see that sometime this year. And again, this is everything you're seeing here is kind of the JavaJet framework. And if you're using version 6 right now, you still have this available to you, and you're able to create JavaJet components. And that could still be useful for you. One nice thing about this method is you can actually take some of the components that we have that are still in JavaJet form. You can actually import them into this component framework or this component designer, and then you can modify them and create a new component based on it. One case might be, for example, if you want to add some functionality to how a connection is made to ActiveMQ or something like that. Like maybe we didn't put a checkbox for a certain property that is available now in ActiveMQ, but maybe it wasn't available at the time that component was written for the version of Talend that you have. You could technically take that component, load it into the component designer, add the property change, which is a very small change, right? And then go ahead and export that out and then use that, right, as a new component. Those are just some ideas of things that you could do. Okay, then best practice 32 is, did you know, I guess, that you can generate your jobs based on JobScript? You can actually generate JobScript and create jobs. This can be very useful. There may be some cases where you want to you have like some metadata that you want to work with that you want to, that you have to generate the jobs, that you want to do something maybe a little more complicated that you can do with, than you can do with the dynamic schema. And so that might be a case of where you do job script generation. So I don't know if you have any other good examples, I guess. I was thinking maybe like the,
Well, we have some of our partners who use this
Yeah.
technique to create metadata-driven engines that generate jobs.
yeah,
Another approach to dealing with thousands of tables is to store all the metadata about the tables using data catalog and write an engine that reads that metadata, generates JavaScript. It's pretty much an XML file.
yeah,
Right? And generating the job script means that you can physically generate the job anytime the metadata changes. So the crank that you turn is to generate jobs. So
Right.
you're using that system to generate the job script that will then generate the Java code. So it's a code generator for a code generator.
yeah,
But can be very powerful, and Yale University uses a technique like this for creating their data lake, because they've got 3,000 some odd tables that are changing all the time,
Yeah.
and they don't want to go in and maintain the jobs. So they just regenerate. Have a cool application for this kind of technique.
okay,
It takes a little work.
Yeah.
building it,
yeah.
but- Sorry? Well, the partner that created this has a suite of tools that they've built. They actually use Neo4j to store a lot of their metadata about the schemas for the source and the target. And then they've written their own code to in Java to generate JavaScript.
Yeah.
So it reads the metadata for the source, it reads the metadata for the target, it goes through their template design that they've stored in metadata, and spits out the JavaScript. Then they bring it into Talend and generates the job code, which you can automate as well using our metaservlet API. So pretty cool stuff. Sophisticated, obviously, but very powerful. And we can always introduce you to these kinds of partners. There's 2 or 3 of them out there that have used this technique for building their special solutions.
All right. So so now we're kind of on the tail end here. We're almost done. So this is we'll talk real quick about some secrets on building some successful jobs. So just like a stool can't stand without 3 legs, right? It's really going to be all about understanding your use case, having the technology that you need to accomplish your goals, and having a methodology so you can do everything the right way, right? If all else fails, be sure that you're consistent about what you're doing. If you're wrong, you want to be wrong everywhere, so you can fix it the same way everywhere, right?
One more
yeah, go ahead. Yep.
Consistency is my number 1 foundational preset.
Yeah.
Pick one.
Yep.
That's the number 1.
Yep.
I don't care about all the others. No,
Yep.
but consistency is the number 1.
Right. Yep.
Can't prioritize after that.
All right. So action is a foundational key to all success. Pablo Picasso, right? Really what we're saying is, start today, right? So you learn some best practices. You're going to build your own development guidelines. You're going to start putting this together and start implementing some best practices. So best time to start is now. Get going, and you can always add to it over time and make it better over time and keep raising the bar incrementally. And that's our recommendation. Don't forget, guidelines, not standards, right? You may run into situations that standards are going to be too rigid for. So be sure that you're flexible enough to handle those. All right, so here's just some parting do's and don'ts. But if you have any questions or what have you, we're around. So, all right. Thank you.